Everything has to be timed so precisely these days. You can't just wander back to the lecture with a cup of tea. Well, you can, but I can't, because I think, I need to be here to start at the right kind of time. Anyway, hopefully, this lecture I'll just post up and on the YouTube and on the Dynamics of Stillness Facebook page too. So you can look at it later if you need to go and have an aperitivo or something instead. So I'm going to start, and I just want to start with a still point. So before we kind of start this little talk, we can just have a little moment of quiet so we can arrive, and I just want, it'd be really nice to bring a little bit of an intention to this still point today on this day, an intention of peace and maybe resolution. So let's just have a quiet moment and come together, whatever you're up to. And just try and get a sense of the stillness that's there all the time, behind the sounds. This kind of deep quiet that's always present for us. Okay, so what's the purpose of me doing this? Well, I started in the webinar, which went out Wednesday last week with the Craniosacral Trust. I just introduced a couple of ideas, and I just wanted to expand on them. I'm dissolving into that ocean of oneness. I see that, that's very nice. So, well, the first reason why we're here is for the love of osteopathy and to support the profession, and just to give people a little food for thought. I'm kind of posing questions, ideas, more really asking questions than giving any answers. It started out actually as I was wanting to give a lecture or two for my diploma of pediatrics students in Ireland, but it's kind of opened up, and there's people coming from as wide as Australia, Colombia, Italy, I know, who are listening in. So I'm going to expand here what we started to discuss last Wednesday then. So, right. Still said, we have an underlying capacity for self-correction initiated by the breath of life. So since Descartes separated mind and matter, we've been grappling to re-find wholeness in our thinking and being. As I mentioned the other day, the conceptus, the fertilized ovum, is a totipotent whole. It's how we start and how we're always trying to refine that throughout our work. We're always trying to get that perfect expression. So we're just going to talk a little bit about the history of this work And I'm just going to talk about a couple of new concepts and models and introduce some elements of wholeness and developing this kind of palpatory felt sense while kind of getting some precision. So again, if you heard me talking, I briefly mentioned Sutherland, who started this when he was looking at a disarticulated skull in A.T. Still's office. And he was looking at the disarticulated temporal bones. And he likened them to gills on a fish and thought they must be meant for motion, more than a breathing motion. So he started experimenting on himself over time with bands and homemade apparatus to lock up certain bones, allow freedom of others, looking at the sutures as joints, the sutures of the skull as joints. So over time, he came up with these 5 phenomena and linked functional movement in the cranium and the sacrum via the dural membrane. He also discovered and talked about the motion of the cerebrospinal fluid, which we're going to talk a little bit about later, the functional motion of the central nervous system around a fulcrum of lamina terminalis, always moving towards lamina terminalis. The cranial bone function, each with its inherent movement, which, when we're starting to do this stuff, we learn intricately each functional movement of each bone and which fulcrum it moves through. And this all connected up by the dural membrane, the much tougher dural membrane, which can pull things out, as we know pretty well, and the connection at the base with the sacrum. So later in his career, he was still experimenting. He was looking at the idea of moving the cerebrospinal fluid by compressing it, by getting onto the occiput, locking the occiput, and not allowing it to go into the inhalation phase, which put in a compression. So through the bones, onto the dural membrane, holding that and allowing that to come to a point of midline in the 4th ventricle where it would undergo an expansion, a real kind of biomechanical expression. And then he started later on talking about EV4, an expression laterally on the 4th ventricle. He started mentioning words like potency, the breath of life, ignition, tide, and terms that started embracing fluid, vitality, and potency in his tissues. So after that time, Magoon, who wrote obviously one of the osteopathy in the cranial field, he largely ignored Sutherland's later in his life terms and focused more on a biomechanical viewpoint of osteopathy in the cranial field. In the old days, the SCTF, Sutherland College of Training, in America, they would do 1-week courses. So they would do 1 week when they would study. This is the time of Anne Wales, Edna Lay, etc. They do a Roland Becker. They would do a week where they would study the CV4, but they would study the anatomy, the physiology, and the mechanics and the biomechanics so intricately. It was incredible. So 25 years ago, Dr. Edna Lay was helping me, I think I mentioned the other day, I don't know, teach. I was the youngest, I was 25 years old, and I was teaching on my first 5-day postgraduate cranial course, and she focused in on me because she thought, well, he can't know what he's doing, he's such a kid, and helped me. And, she was doing these CV4s, showing me how to do CV4s, and it was incredible. The amount of force and strength in her hands that she would hold. And she said, if you lock up those occipits, and stop that movement of the dural membrane, so that locks the fluids onto the 4th ventricle. And she said, if it doesn't last 8 minutes, and if they don't sweat, you haven't done it. You haven't done it. And she was a strong woman from Montana. And my goodness, it was quite a thing. And this biomechanical model where I remember she released one of my my students' occipitomastoid sutures, and one hand was gripped on that temporal, one was on the occiput, and it was almost like it was prized open. It was incredible, right? And it took a while. She's very, very grounded lady. She was holding on for dear life. The poor guy could, whoa. But I'm sure it was groundbreaking, and I was used to working very lightly and delicately. It's incredible. But I suppose what we're talking about is this evolution from a biomechanical model to where we're working more today. And I suppose it's connected very closely with an evolution of science. Roland Becker talked much more about the long tide, about potency and about stillness. He did a lot of work with stillness. James Jealous, embodying the works of the Eric Bletschmidt, the biodynamic embryologist, talking about the movement, the functional movement that we're feeling as being the remnants of the embryonic forces, these biokinetic, biodynamic forces which are in the body. And he's talked more about stillness, about dynamic stillness, like the Taoist dynamic stillness, the long tide, this outside presence of primary respiration, and the Sutherland's wife drew a picture of a house with the doors and windows open and likened it to the ventricular system of the brain. And then that was expanded more to actually the house is the body and the tide is all around us and it focuses us in. And so we're starting to expand into different ways. But now where do we stand? Where does this work stand now? So science is catching up or taking us on, actually, I think. It's giving us new potential explanations, cellular respiration, the function of delta waves in the brain, the gel-sol states of fluids, and field and fluid dynamics. So we'll just talk about these a little bit to get a sense of that. So in a feeling sense, when we feel the fluid body, this perception of fluidity in the body. So what happens, it seems, when someone relaxes and their nervous system quietens down and everything starts to breathe, it starts to become fluid. And the fluid it's like a field, isn't it? It's a fluid field that you can feel beyond the skin. But what is this? So one idea is this whole gel solution state, gel-sol states, gelation. This is this idea of there's this transition between liquid state to gel state. So in a liquid state, the components are fluid. So they're dispersed in a liquid. Everything is free to move about. Okay. So in the gel state, everything gels up. So these subunits bond up on a molecular form and form a network which extends through the whole, which creates structure. So in embryological terms, these states you could think of as biochemical factors like concentrations of particles, salt, also temperature, electrical and electromagnetic changes. And these can cause electrostatic charges to change in molecules. And that could change in turn their stickiness towards each other. So particles can start to become more attractive to one another. So one example of this is crystallization in glass and ceramics. But on a cellular level, cytoplasm actually goes through this process of sol-gel states and this conversion in regards to the actomyosin cycle, which is involved in DNA synthesis and mitosis. Now, this could be thought of as producing cellular motion or locomotion, which could be important in cell migration, and it could be connected to muscle contraction. So at a palpatory level, we can feel fluid, solid states which fluctuate. Are we perceiving something like that? I don't know. So, what about functional metabolic fields? How about a model which includes this kind of functional metabolic field? So, if all organs are functional metabolic fields, how do cells differentiate? So, cell position, so the position the cell is embryologically, it creates form. So position creates form, creates structure in a biodynamic model. So these groups of cells and cells themselves have this metabolic motion with subatomic particles moving in specific ordered ways. So these movements of microparticles occur against resistance from the surrounding tissue. So in any tissue, cells are linked kinetically in movement by the movements of nutrients and waste. So you could see a rhythmic pulsing on a cellular level of repulsion of waste and uptake of nutrients, like a breathing mechanism on a cellular level. This could be the primary respiration that we feel on a cellular level, pulsing in and out. That slow rhythmic pulsation, is that cellular metabolism? So say that the limiting tissues are the epithelia, the cell membranes, and they form a boundary between fluids around cells and the loose inner tissue inside the cell. And they absorb their nutrients and gases and expel waste. So this metabolic motion creates movement out of nutrients, the movement of nutrients. This creates, in turn, canalization or pathways, which in turn create vessels. So you have movement first, or nutrient in grades that creates function, which creates form. So limiting tissues slow down growth. These areas become thickened. For example, the palm of a hand, the cranial base, or the free borders grow faster, become thinner, like the dorsum of the hand and the cranial vault. So we have movement before form. So let's look at fields a little bit more. So Rupert Sheldrake said, each type of natural system has its own kind of field. There's an insulin field, a beech tree field, a swallow field, etc. So these fields shape all the different kinds of atoms, molecules, crystals, living organisms, societies, customs, even habits of mind. So he caused a stir when he suggested that memory is inherent in nature. He suggested the so-called laws of nature are like habits, and that nature's memory depends on a process which he called morphic resonance. So his work suggested that we live in these energetic fields which have collective memory, like a blueprint which in turn creates us. This is a theory that was called causative formation. So these fields have a memory, say, of what it's like to be human, from an atomic to a molecular level, even to that of a cultural or a collective memory and of behavior. It's an interesting idea. So his work resonates with other forms of science, like in embryology, biodynamic embryology, where there's a growing popularity in the idea that we form as a system of fluid fields which move, interact, and relate. And through this motion and relationship creates the perfect form. So in 1922, Alexander Gershwitz said, "The place of the embryonal formative process is a field. in the use of physicists, the boundaries of which, in general, don't coincide with those of the embryo, but surpass them. So embryogenesis, in other words, comes to pass within these fields. Thus we have a visible embryo which is created within its formative field. Now that makes some sense to our palpatory experience of these fluid fields, doesn't it? So this idea has been backed up increasingly through scientific research. For example, in Science, November the 1st, 2019, there's an article on the spontaneous emergence of cell-like organization in Xenopus eggs, which is an African frog. These are really large eggs. So the research showed that the homogenized cytoplasm, i.e. the cell material with no membrane, self-organizes over 30 minutes into compartments, tiny compartments that resemble cells. This shows that the cytoplasm generates itself most of the spatial organism and the cell cycle and function of an early embryo. This is interesting. We, as osteopaths, learn to feel the remnants of these fluid and energetic fields, which, having formed us, maybe help us maintain this perfect blueprint for health. So, cell biology and areas of epigenetics have echoed these views, postulating the powerful effect of these fluid fields in the local and wider environment. So these fields seem to have a role in activating genes. So the microenvironment is seen by its function to activate the genes, not the other way around. So this new biology, people are starting to think that the genes are not the primary factor. More these bioelectric fluid fields and these local environmental microfactors like nutrition fire the genes. So stem cells, which are precursor cells in the body, are the same, but they differentiate into vastly different bones. They start as the same, but they differentiate into bone, liver, fat, depending on their location and their environment. So Sheldrake describes fields as non-material regions of influence. An example of this is the Earth's gravitational field, which is all around us and works through us, but we can't see it. The moon moves around the Earth due to the curve in the Earth's gravitational field. Without it, we'd all float away. So, electromagnetic fields integrate all physical systems, from atoms to galaxies. So, vibrating electromagnetic fields seem to underlie the functions of our brains. They're electric, and our whole bodies, from cellular level to whole systems. So all around us are countless vibratory patterns of activity, which lie within electromagnetic fields, but we can't see them. We can't see them. So some of these fields we can tune into with our phones, radios, TVs. The process of tuning in is called resonance, where we move the dial to a point where the conductor, be it radio or phone, can vibrate at a similar frequency as the frequency, and this allows the transmittance of sound. So in addition to this, there are bigger wavelength fields. There are tiny fields, electron and neutron fields, and microscopic fields within all the particles of matter, which exist as tiny quanta or packets of vibrational energy. So when our body forms, our heart starts to develop at the same time as blood. So it all begins with a flow. The flow of the fluid starts to move as blood forms, and it forms and through motion forms tubes and vessels which fold, rotate in relationship to the flow. The flow came first, and this in turn forms the structure, and that forms the heart. So you could say that the fields start first, the flow starts first. They create maybe the universe with all its structure and function. So let's say we are a field which is constantly interacting with other fields, creating all aspects of life. So Michael Faraday, the English physicist from the early 19th century, was the first to theorize about fields. He discovered magnetism by witnessing the lines of force around a magnet. He saw that tiny iron filings placed around a magnet form ordered lines, showing the shape of the electromagnetic field. An experiment kids do very early on at school. So modern physics has moved this on our thinking, really, with regards to the importance of viewing life as fields. Albert Einstein thought that fields can't be thought of or explained in terms of matter, rather that matter can be explained in terms of energy within fields. So from a wide planetary thinking of relativity to gravitational fields, effects on planets and stars, to the tiny fields within electrons, and the microfields which all particles and matter exist as packets of vibrational energy. You could see everything as fields. So physicists for many years have been trying to link these fields, the tiny to the huge, to kind of come up with a unified field of the cosmos, but they can't quite connect it yet. So the closest they've come to are things like M and string theory, in which the maths add up correctly. But in these theory, we need 10, 11 dimensions for it to make it work. And that could be seen possibly on a very micro level, these 11, 10 dimensional functional fields. So the fields of biology and chemistry are also starting to engage with these ideas, which include things like epigenetics and the ideas of understanding how proteins fold and unfold and the process of crystallization. David Bohm reached an explanation of how these fields connect with his idea of implicate order, in which he explains everything as a total wholeness, in which everything is enfolding and unfolding. So time and space are not separate. In this, he sees everything, the multiverse, as a totality of flowing movement, enfolding and unfolding, again and again and again. This could explain the unanswered questions of quantum physics and other field theories. Sheldrake, in his theory of morphic resonance, talks about everything as a field: memory, instincts, insulin. Nowadays, in relational fields are explored in constellation therapies, which work by setting up family constellational fields. And they use the memory of a specific emotional issue and engage with the field of this by placing people in certain spatial relationships in this constellational field. So the participant actually can feel strong emotional reactions and releases when they actually have never even met the person sometimes. So the nature of these fields, it seems, is to be fluid, to be free, and to relate. So if we start to shift our thinking maybe from the world being a solid structure to our cells and everything being made of interrelating fluid fields, it could help our understanding. So the old osteopaths were highly skilled at palpation, the ones working in hospital environments where they would use their diagnosis, their hands or their feeling sense to diagnose. They could feel what sarcoidosis felt, what hypertension felt, what was a virus, what was a bacteria, what was a parasite, what was grief. Were they feeling these fields? So in a lot of the courses I do, we start trying to develop this feeling sense so we can learn to be very precise with this, so we can have a feeling sensory memory of what these things feel like, so we can pick it up straight away as soon as we see it. And that's, I think, very important. So what we're looking at really is developing some kind of sensory awareness. And as everything is a field, we can see how these fields are affecting the full expression of health, let's say. So let's just talk about another couple of things. I read this actually, and I talked about it briefly last Wednesday, but this is a lovely new theory, and it asks lots of questions, and I'm just going to talk about it in a little bit more depth than I did last week. So the research that came out of Boston University, it was published in 2 different articles on November the 1st, 2019 in Science magazine. So the first article called Deep Sleep Drives Brain Oscillations. So there's 3 types of sleep. There's a shortwave sleep, a light sleep, and a deeper shortwave sleep, and we have REM. So the researchers, Fultz et al., showed that in shortwave sleep, blood flow is reduced by 25%. So this reduced the cerebral blood volume in total by 10%. And they showed that this reduction allows cerebrospinal fluid to flow into the 3rd and 4th ventricles. And they saw this and they thought this was there to facilitate communication between the fluid compartments of the brain and clearance of waste products. So short-wave sleep have different electrical signatures. They differ from the fast activities of the brain when we are awake or in REM. So in shortwave sleep, which is normally driven by delta waves of 0.5 to 4 hertz, so which average 3 a minute every 20 seconds. Now that's very interesting, because that's very much to the rate and rhythm of what we're feeling when we're going on to a normal slow rate. 3-4 cycles a minute every 20 seconds. And they've shown that these movements have been shown to enable neurons to form coherent assemblies that propagate meaningful information to other networks. This is involved in the formation of long-term memories. So in shortwave sleep, the neocortex, the frontal lobes, is active, and the dialogue between the cortices is maintained, the 2 sides, which they call callosal volleys, which is information passage via the corpus callosum from one hemisphere to the next, to the other. This is increased in shortwave sleep, but at the same time, the cortex is shut off from the rest of the environment through our senses, because the nuclei that usually relay information from the environment via our senses becomes unresponsive. We're asleep. But there's this high level of activity. And within it, though, the energy turnover of the brain is reduced. So is the metabolism of oxygen. So cerebrospinal fluid, as we know, is produced in the choroid plexuses and flows from the lateral ventricles into the third and then the fourth ventricles. It then passes into the subarachnoid space surrounding the brain and the spinal cord. So there it usually moves along the convexity to the top of the brain, where it's reabsorbed into the arachnoid granulations of the dural venous sinuses. So this fluid dynamic change could also happen on a cellular level. So the quiet sleeping neurons shrink, release fluid, then the fluid rushes in, clearing metabolic waste, like a metabolic respiration. So Furtz from Boston University describe a reversal in the direction of flow of cerebrospinal fluid during shortwave sleep. So they think that the CSF flows from the subarachnoid space into the third and fourth ventricles. Now, what does that sound like? That sounds like a CV4 maybe. So it seems the waves of the cerebrospinal fluid inflow are generated by the slow electrical brain oscillations, the delta waves, and the corresponding fluctuations in blood flow and the cerebral blood volume. So the CSF flow mediates this mixing of brain fluids, and it facilitates signaling through volume transmission of neuromodulators, helps dispose toxic metabolic wastes. This slow CSF oscillation could be important in the disposal of waste products such as toxic brain proteins and other elements that could cause neurodegeneration. Also, they showed that the CSF has particular drainage pathways around the small vascular pathways. Up till now, they didn't consider that there were any lymphatic pathways in the brain at all. So this is what they call the glymphatic theory. So it suggests that during shortwave sleep, the interstitial and the CSF fluid flow moves rhythmically and mix along what has been called glymphatic pathways, which surround the arterioles and takes them towards the venules. So when the brain-wide delta pulsations occur every 20 seconds, they cause the CSF to inflow into the third and fourth ventricles. The CSF and the interstitial fluids flow in a slow, rhythmical motion around the blood vessels of the brain. Makes sense, doesn't it? Because that's what we're feeling when we're working. So this reversal of the cerebrospinal fluid during shortwave sleep facilitates a mixing of the subarachnoid and the ventricular fluids and serves as a communication between them. This may serve to help keep the small apertures between the ventricles and the subarachnoid space open, maintaining free flow between the choroid plexus and the subarachnoid space. So this could prevent accumulation of waste products within the brain and preserve a low intracranial pressure. So disturbances in shortwave sleep, which accompany aging, depressive disorders, neurodegenerative disorders, dementia, could be linked to this. In the future, they may be able to measure the CSF dynamics in shortwave sleep as a biomarker. Galen, the Greek physician from Pergamon, around 150 AD, but he lived in Rome. He wrote hundreds. He is the most widely written writer of the time on anatomy and medicine. But he was the first to link brain fluids and restoration. He thought the brain fluids escaped during daily activities into the body, and then sleep rehydrates the brain. Well, that's very similar to what we've seen. Pretty clever of him. So this process of slow rhythmic pumping is only thought to occur in shortwave sleep. Now, there are more delta waves measured in females than males, and they reduce in all of us from about 40 years old, which could be why sleep is harder as you get older. So delta waves originate in two places: the thalamus, which are the walls of the third ventricle, the reticular fibers, and the cortex above the optic chiasma, both midline structures linked to the third ventricle, and they've been shown to affect pituitary function. Now these, again, are very important areas when we're working with patients. So let's talk a little bit about ideas of potency, ignition, and biophotons. The pineal gland, the eyes, the third ventricle, the pituitary gland, the blood itself, and other parts of the CNS respond to light, to photons. So a photon is a type of elementary particle. It's a quantum of the electromagnetic field, which includes light and other waves. So its mass is always zero, but it moves and can move at the speed of light in a vacuum. So the energy of a photon is 3 × 10⁻⁹ joules, tiny. So we only can feel them in huge numbers. So a watt from the sun carries 3 × 10⁸ photons per second, which is why we feel the heat of sun rays. This could be explained in terms of quantum mechanics as having both wave and particle duality. Both these aspects can be measured but are part of one phenomenon. Biophotons, which are photons in our biological spheres, are produced, have been shown to be produced by cells at the rate of tens per second per centimetre. So cells have been shown to produce these rhythmic bursts of biophoton streams. This is research from Russian at the Lebedev Institute in Moscow by Mayborov et al. These bursts are similar to binary digital messages shown in plants to increase growth rate by 30% and have been shown to help in egg growth. So neurons are particularly open to light and photon communication. So neurons are large, colourless cells with wide connections. They have active metabolism and they generate photons. So the brain and the spinal cord are protected from external light by bone and connective tissue. There's little interference, so they become quite sensitive to this biophoton exchange. So this idea of bioluminescence is the process that's been linked to a form of cellular communication. So neurotransmitters have the highest bioluminescence, like a fluorescence, a light. Serotonin, dopamine, norepinephrine. This could allow us to start to see the brain as a light holographic computer. So connective tissue and fascia have a lot of sensitivity to photons and light. And there's been lots of research about this communication in connective tissue being faster than neural networks. So maybe because they move at the speed of light, which is slower than the biochemical exchange in nerves. Who knows? It's interesting. So, some people say that biophotons are mechanisms for tissue healing, but others refute that strongly. So when we're feeling light ignition, is that related to this? I think so. So let's talk for a second about distance healing. If we're on this subject, how's that even possible? How can there be such incredible precision, effectiveness, like in cases which you can do far more beyond what you can with your hands on? What's that about? Stuart Firestein, who's a neuroscientist in Columbia, says what we don't understand is the beginning of true science. So is distance healing related to quantum entanglement? Waves and particles. Two waves at the opposite side of the world in quantum entanglement, if one wave collapses or moves in a certain direction, its twin, the other side of the world, will do the opposite. What's that? Or quantum coherence, where space and time, or space or time, have no effect on this coherent action of waves at no distance and no time. So what are we feeling here? This non-local action faster than the speed of light. Einstein thought of this as the weirdest thing in science, understandably. Spooky action at a distance, he called it. But in distance healing research, it comes out strong. So 2 meta-analyses of distance healing, one by Schmidt et al., examined hundreds of research projects, for example, functional MRIs, EEGs, ECGs, heart rate, electrodermal activity, etc., and found that distance healing could have physiological effects on yeast, bacteria, connective tissue cells, red blood cells, and also animals' recovery speed from anesthesia and wound healing in mice. Crawford and his team did a meta-analysis of 90 or so randomized trials, and they found that distance healing had a higher validity of 75% effect than hands-on treatments. Higher. It's amazing. But all of the research shows proof of principle, meaning it works. But how does it work? More research is needed. But we're just at the edge of this, and always when we're talking and when we're examining these ideas, we're always looking at the potential, the incredible potential for what we do as healers, as osteopaths, and it's limitless. And that is incredibly exciting to me. And sometimes we're just limited by our thinking about it and by our potential thinking about it. So these are just thoughts and ideas of potentialities of what we're doing. So on the courses that we're doing, which is to do with developing palpatory precision, and we talked about this as a course that we're going to do in London in early October, and we're going to do I'm going to do a course in late end of October in a beautiful location just south of Florence in Italy. We're going to look to do a course, I think, in early spring in Ireland, maybe middle spring in Australia, and then someone was on to me yesterday about doing one in France. So watch this space about this. But we'll look at specific things. We'll look at trying to develop our sensory awareness and to feel functional anatomy in a very precise way, to feel kind of internal, external fulcrums and develop our connection with this long tide. So I think what we'll do is take specific themes, maybe we'll do different ones each time, and explore them in depth, kind of gaining a real felt sense experience of very complex processes, but learning at the same time to address really challenging health issues, like the idea of down-regulating the amygdala in anxiety disorders, that facilitated amygdala that has been facilitated actually grows when people have chronic anxiety, and how you can act to down-regulate it. Or looking at very specific hippocampal blood supplies and toxic markers in tendencies to dementia disorders. Things like that. Light, potency in ignition, looking at ignition on a cellular level in autoimmunity and depression and things like that. So these are things that we'll try and explore, and the best way is to explore it all together. So anyway, this is, if you have any questions, email me, because I will try and answer them. The next session, I think, is going to be, I'm going to talk about prematurity, if people are interested, and discuss our potential effect in prematurity in detail. But if you email me a question to Clonmel, CLONMEL, osteopaths @gmail.com, I will try and answer any questions at the beginning of the session, which is on the 15th, at the same time, same place. In the meantime, I think we should have another little still point just to finish this off. And I think for me, it's really important at this moment in our planet's evolution that we remain connected to our health. And I think we have to take time to sit in stillness and allow the unfolding of wholeness within ourselves and wider into the world. So can we just maybe sit for a second to finish up and have a moment? I wish you well. Speak to you soon. Bye.